Hi, it's Miss Molesbury, and this is the last Algebra 2 lesson for the year. I can almost hear you cheering through the screen. So what we're going to do today is put it all together. We're still going to solve exponential and log equations, but we're going to end with a fun word problem day, obviously. How else could we end the year? So let's jump right in. We have 3 different scenarios we're going to work through. Number 1 says the pH scale is a scale for measuring the acidity or alkalinity of a substance, which is determined by the concentration of hydrogen ions. The formula for pH is pH equals negative log of H+, where H+ is the concentration of hydrogen ions in moles per cubic liter. Solutions with a pH value less than 7 are acidic. Solutions with a pH of 7 are neutral. For example, plain water has a pH of 7. Okay, so that's a lot of information, and if you're not a science person, you might be like, what in the world's going on? Well, the important part, here's the equation. H plus is the hydrogen, or concentration of hydrogen ions, and pH is for the pH, right? pH is just the pH scale. So, A says that hydrogen concentration in orange juice is 0.000199 mole per cubic liter. Determine the pH. Okay, so it just wants us to use the equation. It's giving us a value to plug in for H plus. So to find the pH, negative log of this decimal. The part I'm solving for is already isolated, so this is just plug it into your calculator, see what we get. So the pH is, so go into my calculator, and remember we can just use the log button next to the 7, and I can be on my home screen, so negative log of 0.000199. Enter. 3.701. I'm going to go ahead and keep rounding to 3 decimal places like we've been doing the past few classes, unless it tells me to do something else. So 3.701 common log is what we just used. And then it said at the end, determine if it's acidic or alkaline. And solutions with a pH less than 7 are acidic. 7 is neutral, and I guess higher than 7 is alkaline. So this is less than 7, so this is acidic. Okay, great. Let's keep going. The concentration of hydrogen ions in baking soda is 5.012 times 10 to the negative 9th moles per cubic liter. So remember, this is just a really tiny decimal. It means 10 to the negative 9th would move that decimal 9 places to the left. Determine the pH level of baking soda and then state whether it's acidic or alkaline. Okay, this sounds very similar to what we just did. It's going to be more of a calculator question than anything else. Okay, so we need to find the pH. So negative log of 5.012 times 10 to the negative 9th. We're going to type it in the calculator just like that and see what we get. Okay, so to the calculator we go. Negative log of 5.02 times 10 to the negative 9th power. Oh, and I get 8.2992. So I guess I'm going to stick with 8.299. .299. And that's bigger than 7, so it must be, it's not 7. So it's not neutral, it must be alkaline. Great. And then C says vinegar has a pH of 2.2. Determine the concentration of hydrogen ions in vinegar. Okay, so now it finally gave us instead the pH, and it wants us to solve for the hydrogen. So this time we're going to have 2.2 equals negative log of H plus, because we don't know the hydrogen concentration. So just like we've been working on the past few classes, isolate the log, meaning I have to deal with this negative sign. You can think of it as a -1. So divide by -1 on both sides. 2.2 equals the log of H plus. Now to solve for H, I'm ready to rewrite this as an exponent. So remember we said common log, this has a base of 10. So using the wraparound method, start at your base, 10 to the -2.2 is going to equal the argument. So I know I'm out of room here, but 10, loop it around, and it's going to let us free and isolate the hydrogen ions, like specifically the variable. Okay, so typing 10 to the -2.2 in the calculator, 0.006. I guess it's in moles per cubic liter. Okay, we're just gonna say that is our hydrogen concentration. So what you're gonna see today is I'm gonna give you scenarios that you may have no background knowledge about if you haven't taken chemistry, right? Or if you haven't, we have population growth coming up. And then the third question is actually kind of morbid. The point is, all of these problems are going to give you an equation, and it's just a question of, do you understand what to use for each variable and then how to solve no matter the variable that you're looking for. So let's try another one. Gina is a social media manager, and she uses the model for continuous population growth to project the monthly increase in the number of followers on her clients' social media sites. Recall that the formula for continuous population growth is N of T equals N naught, so initial population. We've used PERT for P here before, but that's fine if we use a different variable. But this is N times e to the RT power. State what each quantity represents in terms of the problem situation. Okay, well, it looks like we just talked about initial population, so the initial number of clients, the initial followers, I guess, and then the rate that they're changing and the time. And remember, E is not a variable, E is a number. We'll find it by typing second and divide in our calculator. So Gina claims that when she started working with an up-and-coming boy band, they had 18,450 online followers, and she was able to increase their followers by 26% per month. Write a function to represent the number of online followers that the boy band had after T months. Okay, so our equation would be the future, like N of T here means the future followers depend on the time. And that equation is 18,450 was our initial amount of followers times E. I'm still going to remember to move the decimal 2 places to the left. 0.26. And then I don't know the number of years here. It said to write the equation in terms of T after T months. So that's it. And now I'm sure when we turn the page, we're going to have follow-up questions with this equation. So if Gina started working with the band on May 1st, how many online followers did they have by September 1st? Okay, T here is months rather than years. So let's count May 1st. So we have the whole month of May, June, July, and August. and then it's September 1st. So you can double check me, but it looks like 4 full months passed there. And then we are going to plug in 4 for t. So n of 4, oops. It's the starting amount. E, we'll type in the calculator and raise it to the 0.26 times 4. So the number of followers in 4 months is, calculator time, 18,450, second divide, raise it to the 0.26 times 4. You could use a multiplication sign or parentheses, either way. And since we're talking about people, no decimals, please. So I'm going to keep this at 52,199 followers. Okay, great. And the next one says, how long did it take the band to surpass 100,000 followers? Okay, so let's work this out. I'm now given a number for my followers. And I don't know t. So my goal is to solve for t. So we're going to have to isolate the exponential part, meaning we're going to need a log here, specifically a natural log, because I see e. So let's isolate that first by dividing both sides by 18,450. Okay, so I know it's tempting. We're going to go to the calculator, but I don't want you to put this as a decimal. We want to leave this exact. So you could either leave it how it is on the paper, or you can let your calculator help you reduce it. So in the calculator, I'm going to make a fancy fraction by pressing alpha y equals enter. I'm going to type 100,000 over 18,450. Oh, well, okay, I think on the school calculators, hang on, I have one next to me. Alpha y equals enter. 100,000 over 18,450. Oh, the school calculator gave me 2,000 over 369. So the other option I could try, let me hit math. The first option is fraction. Oh, hang on, sorry. Calculate 84.
You are not
I guess I have to wait.
You're not a two.
Sorry, that's exciting. Okay, I'm trying to make that a fraction. It didn't do it. So I don't know if it's this app I have on my iPad's not as good. Let me try typing it. I know it can reduce by 10. Let me try typing it that way. So all I'm doing is getting rid of the 0 on the end. No, I don't know. I guess this app doesn't do that, but hopefully you're using a school calculator. It helped me reduce it down to 2,000 over 369. Sorry for that delay. And you could also just leave it this crazy fraction as well. Okay, now that the exponential part is isolated, we're ready for a log. So start at your base. E tells me I need a natural log, and loop it around. The natural log of this fraction equals 0.26t. Okay, so then to solve for t, we're going to have to divide by 0.26. So last line over here, the natural log of this fraction is going to get divided by 0.26. This is my exact answer. So let's go type in the calculator and see what it's close to. Okay, so I'm going to do the natural log of 2,000, and you could use a fraction as well, divided by 369, divide that whole quantity by 0.26. Okay, 6.500. So my time here is going to be approximately, change those equal signs, let me make it a little neater, approximately 6.5 months. And the question just asked how long. It didn't ask me what month would it be during or anything like that. So I can stop there. So you will have questions on your next test that involve PERT, where you have to solve for an unknown time, and we want to do it in exact form. We don't want to just rely on the table and the calculator. I want to see your solving steps. Okay, the last one is kind of the morbid one because it's about a formula that a coroner uses. So that's okay. Maybe if you are into any sort of true crime shows or podcasts, I don't know. Let's just not make it too weird. Okay, so it says a coroner uses a formula derived from Newton's law of cooling, a general cooling principle to calculate the elapsed time since a person has died. The formula is T equals -10 times the natural log of T minus R over 98.6 minus R, where T is the body's measured temperature in degrees Fahrenheit, R is the constant room temperature in degrees Fahrenheit, and T is the time elapsed since death in hours. Okay, great. Just a really great application of logs here. Okay, so we have body temperature, we have room temperature, and we have time. So it says at 8:30 a.m., a coroner was called to the home of a person who had died. The constant temperature of the room where the body was found is 70 degrees Fahrenheit. So I'm going to say that is the room, R. At 9 a.m., the body's measured temperature was 85.5 degrees Fahrenheit. Use this body temperature to estimate the time of death. Okay, well, T is the time. I think I have both I guess lowercase t is the time. I have capital R, the room temperature. I have capital T, the body temperature. So I think this is a straight plug-in question. -10 times the natural log of 85.5 minus 70 over 98.6 minus R is still 70. Okay, so I'm going to go ahead and plug this into the calculator. And I am going to use a fraction here. So -10 times the natural log, and then alpha y equals enter of 85.5 minus 70 over 98.6 minus 70. Close these parentheses. And I get 6.126. I guess I'm going to round it to. So 6.126 are the number of hours ago that this happened. So let's think about if this is 9 a.m., a little past 6 hours ago would be, a little before, and I won't make you come up with the exact amount, but it'd be a little before 3 a.m. Okay, so, and that's 6 hours from when it was measured, which was 9 a.m. Okay, let's try another one. A more accurate estimate of the time of death is found by taking 2 or more readings and then averaging the calculated times together. So at 9:30, the body temperature was 82.9. So we want to do this and find the other estimate, and then we'll average them. Oh, we may not do our exact average here, but we'll see what we come up with. Again, the whole point of this question, when you're like, what would I be asked to do? I'm not going to give you this exact formula on a test. I'm just going to give you a formula, and you're going to have to decide, how do I use the formula? Where do I plug numbers in? And then how do I use my calculator to help me solve? Okay, so in the calculator, let's go type this one. -10 times the natural log of alpha y equals, enter, 82.9 minus 70. And you could do this math in your head too. You could say, oh, that's 12.9. And then 98.6 minus 70. 7.962. So that means almost 8 hours ago. 7.962 hours ago. And this is from 9:30 a.m. So let's see. Almost 8 hours. Before 9:30 a.m. would be around 1:30. And we're not going to do the exact amount there, but what we could do, like the exact number of minutes, what we can do is we could average our answers from A and B. So average of A and B. So we could add 6.126, 7.962, divide by 2. I could have left those exact in the calculator. Okay, I get 7.044. The tricky part about this is then which time do I subtract from? So probably more accurate here is going to be if I said, okay, take these times at the end and what is exactly between 1:30 and 3 a.m. Those are 90 minutes apart, so about 2:15 a.m. approximately. So this is about 7 hours ago from their average time of like 9:15. So again, this is just us taking this problem maybe a little more seriously than I should here, but about 2:15 a.m. would be our estimated time using the average of these two times that we found and time since death. So, man, that's not really an uplifting way to end these videos for the year, but still, applications of math can be exciting. Okay, I should stop this before it gets any more awkward. The good thing is you've learned it all this year, and I'm excited to see how pre-cal goes for everyone as well. Of course, I'll still be here to help if needed. But yeah, let's go ahead and finish the year strong. One test left to go.